In this episode, we're going to talk about using AI to help write code while still treating security as a first-class requirement, not an afterthought. For beginners, it can feel like a miracle to describe what you want and watch a working function appear, especially when you're still learning syntax and structure. The risk is that code that works is not always code that is safe, and AI is very good at producing code that looks plausible even when it contains subtle vulnerabilities. When people are new to secure coding, they often believe that security problems are rare and obvious, like a dramatic hack scene, but most vulnerabilities are small and quiet. They are the result of missing checks, unsafe defaults, and incorrect assumptions about how data flows through a program. If you use AI as a code generator without guardrails, you can accidentally speed-run those mistakes into your project. The goal of using AI in secure coding is not to forbid generated code, but to adopt habits that reduce the chance of injecting vulnerabilities. That means thinking carefully about inputs, outputs, trust boundaries, and how the code will be used in the real world, then verifying that the generated code matches those expectations before anyone relies on it. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good way to begin is by recognizing what AI is actually doing when it generates code. It is not running your program, and it is not reasoning about the full environment the way a human engineer might. It is producing code patterns that resemble code it has seen before, guided by your prompt and the context you provide. That can be extremely helpful for getting started, but it also means the model can accidentally choose an unsafe pattern that is common in older examples or that is acceptable in one context but dangerous in another. Beginners sometimes assume that because the model sounds confident and the code compiles, it must be correct and safe. In reality, secure coding is about constraints. Who can call this function? What data can they send? What should happen when the data is malformed? And what should never happen even if the attacker tries? If your prompt does not include these constraints, the model may not include them in the code. Even if you include them, the model may implement them incompletely or incorrectly. So the first mindset shift is to treat generated code as a draft that needs review, not as a finished artifact. The central security concept behind many code vulnerabilities is untrusted input. Untrusted input is any data that originates outside your control, such as user form fields, API requests, uploaded files, URLs, or data pulled from external systems. The most common beginner mistake is to treat input as if it will be well-formed and friendly. Attackers do not follow those assumptions. They actively violate them. When AI generates code, it may skip input validation because many simple code examples do. It may assume that a string is a safe file name, that a number is within expected range, or that a parameter is present. Those assumptions can create vulnerabilities like injection, path traversal, insecure direct object references, and denial of service through oversized inputs. A secure approach is to define, in plain language, what inputs are allowed and what must be rejected. Then you ensure the code enforces those rules at the boundary as early as possible. Beginners should learn that secure coding begins before the code, in the definition of input constraints and trust boundaries. AI can help write checks, but humans must decide what the checks should be. One of the most common vulnerability families that can be introduced by generated code is injection, which happens when untrusted input is interpreted as code or a command. This includes SQL injection, command injection, and injection into templating systems or interpreters. AI-generated code can accidentally build queries by concatenating strings or construct commands by stitching user input into a shell call, because those patterns are easy to demonstrate in short examples. Secure coding avoids those patterns by using parameterized queries and safe APIs that separate data from code. For beginners, the key is to recognize the difference between a value and an instruction. A user should be allowed to provide data, but they should never be able to alter the structure of a query or a command. When you use AI to generate code, you should explicitly request safe patterns, and you should review the output looking for string concatenation around queries and commands. Even if you do not know every detail of a language, You can learn to spot the smell of unsafe assembly of instructions. If the code is building an instruction by gluing strings, that is often a red flag. Authentication and authorization are another area where generated code can create risk because the model may include simplistic checks that are not sufficient for real systems. Authentication is the process of proving who someone is, while authorization is the process of deciding what they are allowed to do. Beginners often mix these up, and AI can reinforce that confusion by producing code that checks a user is logged in but does not verify they have permission for a specific action. A common mistake is to rely on client-side checks, such as trusting a value in a request that claims the user is an administrator or trusting a user ID parameter without verifying ownership. A secure approach is to treat identity as something validated by trusted mechanisms and to enforce authorization on the server side for every sensitive operation. When AI generates code for an endpoint or a function, you want to ask what resource is being accessed and who is allowed to access it. Then you want to see those checks implemented explicitly. Beginners should remember that authorization is not a one-time check at login. It is a repeated check at each decision point. Code that performs an action without verifying permission is a common path to privilege escalation and data exposure. Secrets handling is another area where AI-generated code can be risky because the model may include credentials directly in the code for convenience. Beginners sometimes copy that pattern because it makes the example work quickly. Hard-coded secrets are dangerous because code is shared, stored in repositories, and often visible to many people. If a secret is embedded in code, it can leak through logs, screenshots, backups, and accidental publication. A secure approach is to keep secrets in a dedicated secret store and access them at runtime through controlled mechanisms. Even if you are not implementing those mechanisms in a beginner project, you should still avoid hard-coding real credentials. When using AI to generate code, you should explicitly ask for placeholders and for patterns that separate configuration from code. You should also review generated code for any embedded tokens, private keys, or sample secrets that could be mistaken for real ones. Beginners should develop the habit that secrets do not belong in source files. That habit prevents a large class of accidental exposures. Error handling and logging can also introduce vulnerabilities when generated code is used without review. AI may generate verbose error messages that expose stack traces, internal paths, or sensitive environment details. That can help attackers map your system and find weaknesses. At the same time, insufficient logging can make it hard to investigate incidents. The secure balance is to log enough detail for internal diagnosis while returning minimal safe error messages to users. Beginners should learn that user-facing errors should be simple and generic, while internal logs should capture context without including sensitive data. Another common issue is logging untrusted input directly, which can lead to log injection or to sensitive data being stored in logs. When you review AI-generated code, look for how it handles exceptions, what it returns to callers, and what it logs. If it prints raw input or dumps internal state into responses, that is a red flag. Secure coding is not only about blocking attacks, it is also about avoiding information leaks that make attacks easier. Dependency usage is another way AI-generated code can inject risk, because the model might suggest using a library without considering whether it is maintained, safe, or appropriate. Beginners often trust library names because they sound official. In real secure coding, you want to use trusted dependencies, pin versions, and minimal packages. While we are not getting implementation heavy here, the principle is that every dependency is part of your supply chain. If the code includes a dependency that is unnecessary, you have increased attack surface. If the code uses outdated patterns or insecure APIs, you may inherit known vulnerabilities. When you use AI to generate code, treat dependency suggestions as proposals, not decisions. Ask, do I really need this? And is there a safer standard library approach? If you do need a dependency, you should verify its trustworthiness through your normal process rather than assuming it is safe because it appeared in generated code. Beginners should remember that convenience can hide risk. Choosing fewer, more trustworthy components is often safer than assembling a stack of random helpers. Now let's connect these ideas to a practical workflow that reduces over-reliance on AI code generation. The first step is to define the security requirements in the prompt, such as input validation, safe handling of authentication and authorization, and safe error behavior. The model cannot guess your risk tolerance, so you must state it. The second step is to review the generated code with a security lens, looking for the common failure points, string-built queries, missing authorization, hard-coded secrets, unsafe file handling, verbose errors, and unbounded loops or memory use. The third step is to test the code's behavior with adversarial thinking, meaning you imagine what happens if an attacker sends weird inputs, huge inputs, or malicious strings. You do not need to run labs to do this conceptually. You can reason about what the code would do and whether it has explicit checks. The fourth step is to use independent validation, such as code review from another human or analysis tools, before deploying. For beginners, the important part is the mindset that AI accelerates drafting but does not remove the need for security review. When you make review a routine, you reduce the chance of silently embedding vulnerabilities. It is also important to talk about the kind of tasks where AI is most helpful and least risky for beginners in secure coding. AI can be great at generating boilerplate structure, explaining concepts, and proposing patterns that you can then adapt. It can be helpful for writing tests, documenting functions, and refactoring code for clarity, which can indirectly improve security by reducing confusion. The risk grows when you ask the model to generate security-critical code without strong constraints, such as authentication modules, cryptographic routines, or access control logic. Beginners often want to start there because it feels advanced, but those are the places where mistakes have the largest blast radius. A safer approach is to use AI for scaffolding and for explanations, then rely on established, reviewed mechanisms for security-sensitive functions. That does not mean you avoid learning those topics. It means you learn them carefully and validate them thoroughly. If you treat AI as a teacher and assistant rather than as the ultimate implementer of security logic, you reduce risk while still benefiting from speed. To close, using AI in secure coding is about getting the benefits of fast code generation without importing vulnerabilities through unsafe patterns and unverified assumptions. Generated code is a draft shaped by patterns the model has seen, not a guarantee of correctness or safety, so you must supply security requirements and review outputs carefully. The most common risks include untrusted input handling failures, injection through string-built instructions, missing authorization checks, hard-coded secrets, leaky error messages, risky logging, and unsafe dependency choices. Practical safe use relies on human verification loops, defining constraints, reviewing for known smells, reasoning about adversarial inputs, and using independent checks before deployment. When you treat the model as a productivity tool that accelerates careful engineering rather than replacing it, you can write code faster while still protecting the systems and people that code will touch. Secure coding is ultimately about disciplined boundaries and validation, and those disciplines matter just as much, if not more, when the code comes from an AI assistant.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.